Hi, it's Mrs. Moret with some help on today's assignment, Unit 2, Lesson 21, which was solving rational equations, and you're doing numbers 1 through 7. So the big idea for solving rational equations is to try and create an equation, an equivalent equation that doesn't include any fractions. And to do so, you want to multiply by the denominator. And so that's going to be our first step here on number 1 where we're solving this equation. So we've got x minus 1 equals x squared minus 4x plus 3 all over x plus 2. And so if we multiply by this denominator, x plus 2, then we'll no longer have a fraction to worry about. It makes our equation a little easier to solve. And so these are eliminated, and I have x plus 2 times x minus 1 equals x squared minus 4x plus 3. So there's a couple different ways I could solve this. I'm going to go ahead and multiply this out. So x plus 2 times x minus 1. Pretty easy to multiply this with a little multiplication box. So x squared, negative 1x, 2x, and then down here is negative 2. All right, so we have x squared. Let's see, this is minus 1x plus 2x, so it's minus x altogether. Or sorry, plus x altogether. And then minus 2 equals x squared minus 4x plus 3. So typically what we would do now that we're at this step in the equation is we would move everything from one side of the equation to the other using the opposite operation because we've got a quadratic and we want one side to equal 0 and then either factor or use the quadratic formula. But I noticed that both of these contain just x squared. So if I start moving terms from the right side to the left side, I actually completely eliminate the x squared. And I'm going to use that to my advantage because now what's left is just a linear equation, x minus 2 equals negative 4x plus 3. And so I'm not going to have to worry about factoring or using the quadratic formula. So here's my equal sign. I want to move variable terms. So the minus 4x, I'm going to add 4x to both sides. And then the constant terms to the other side. So minus 2, so I'm going to add 2 to both sides of the equation. And now we have, this is 5x. And 3 plus 2 is 5. So divide, and we get x equals 1. All right, on number 2, I'm going to take the same initial strategy, which is to look at the equation. 4 divided by 4 minus x equals 5 divided by 4 plus x. And I'm going to multiply both sides of the equation by the denominators. So as long as you multiply both sides of the equations by the same thing, then you haven't changed the value. So one denominator is 4 minus x. The other one is 4 plus x. I'm going to do the same thing over here. 4 multiplied by 4 minus x times 4 plus x. Okay, so on the left side, the 4 minus x's cancel each other out. And on the right side, the 4 plus x's cancel each other out. So that gives us 4 times 4 plus x equals 5 times 4 minus x. So 16 plus 4x when I distribute. 20 minus 5x over there. Okay, so same thing as above. I'm going to move the variable parts to one side, the number parts to the other, the constants. So I'll start by adding the 5x. Here's my equal sign. Add 5x and add it there. So then the constant, I'm going to subtract 16. And so altogether, I have 9x on the left, and 20 minus 6 is 4. So divide by the 9, and I'm just going to keep that as a fraction, 4/9. All right, on number 3, it says to show that the equation 1 over 60 is equal to 2x plus 50 over x times x plus 50. Show that that is equivalent to x squared minus 70x minus 3,000 equals 0. So I'm just going to do some rearranging, really, to do this. And I'll start with that first step that we've been doing on number 1 and number 2. I'm going to get rid of both of the fractions in the problem by multiplying both sides of the equation by the denominators. Okay, so here's the original equation, and I'm going to multiply by the 60 and the x times x plus 50. So 60 times x plus 50. And same thing on the other side, times 60 times x plus 50. Okay, so I'm going to go ahead and put my line down the equal sign so I can kind of keep track of everything, see where all the terms are, and all right, and get that into the window. All right, oh, this should be a 60, not a 6. All right, so the 60s over here cancel out. I have x times x plus 50 times 1. So really, it's just x times x plus 50. And then over here, x times x plus 50, x times x plus 50. So I'm really just multiplying that by 60. Okay, so now I'll clean up both sides by distributing. This is x squared plus 50x. $60 times 2x is 120x. And 60 times 50 is 3,000. And then this is a quadratic, and so the strategy for solving quadratics, like I said before, is to subtract each term over here so that the equation is set equal to 0. So we're going to subtract the 120x and subtract the 3,000. So over here we will have, this is 0, this is 0, so altogether 0. And then on the left side, there's just x squared. It's not matched up to either of those terms. 50x minus 120x is negative 70x. And then the minus 3,000 doesn't have a constant above it to subtract from, so it just stays minus 3,000. And we can see this matches what the prompt is asking us to show. That it's equal to x squared minus 70x minus 3000 equals 0. All right, moving on to number 4. So number 4 has to do with distance, rate, and time. So Kyron jogs at a speed of 6 miles per hour when there are no hills. He plans to jog up a mountain road, which will cause his speed to decrease by r miles per hour. So instead of jogging 6 miles per hour up that hill, it'll be 6 minus r because the hill will slow him down. Which expression represents the time in hours it will take him to jog 8 miles up the mountain road? Okay, so we know we've got distance equals rate times time. So if the distance is 8, and his rate is typically 6 miles per hour, but it's being slowed down. So we'll write 6 minus r. So distance equals rate times time. And then we want to know which expression represents the time. So if I solve this for t, just do so by dividing both sides by 6 minus r. So we have t equals 8 divided by 6 minus r, which is option D. On number 5, we're taking this rational function and rewriting it in this form where we see the constant, which is going to end up being the horizontal asymptote. And so I'll just write it out. G of x equals, we're going to split apart the divide by x. X divided by x plus 10 divided by x. X divided by x is 1, and I can't simplify 10 divided by x. So that looks like option number B, or option B, I guess. G of x equals 1 plus 10 divided by x. On number 6, there's 4 equations to solve, and they're all just really similar because we have some sort of constant is equal to a linear divided by a linear expression. And so to solve that, I'm going to start each one by multiplying by the denominator of the side that has the fraction. So I'm going to multiply here by 7 plus x, and same over here. That says 7 plus x. So these are eliminated. They cancel each other out. 7 plus x times 10 is equal to 70 plus 10x, and that equals 1 plus 7x. Okay, so I'm going to move the 7x over by subtracting, and then also move the 70 over also by subtracting. Remember, you want to keep both sides of the equal sides balanced. So on the left side, we get 3x, and that equals 1 minus 70 is negative 69. And so then just divide by the 3, and you get x equals negative 23. Okay, every single one of these is that same process. Multiply by the denominator. And so these cancel each other out. And I need to open my calculator. So 12 times 0.2 is 2.4. So 2.4 plus 0.2x equals 6 plus 2x. Okay, now we're going to follow the same process. Move the x terms to the left side of the equation, the constants to the right side. And so I'm going to subtract the 2x from both sides. And then subtract the 2.4 from both sides. So 0.2x minus 2 is going to be negative 1.8. Negative 1.8x equals 6 minus 2.4, which is 3.6. And so I'm going to divide that by the negative 1.8. And we get x equals, I think it's negative 2. Yeah. Okay. On C, again, I'm going to use the same strategy. I'm going to multiply both sides of the equation by this denominator, 0.5 plus x. 0.5 plus x. So 0.5 times 0.8 is 0.4. So 0.4 plus 0.8x equals x. So this time I'm just going to move the 0.8x to the other side since there's just an x over here. So minus 0.8x minus 0.8x. And that gives me 0.4 is equal to 1 minus 0.8 is 0.2. So then divide by 0.2 and you get x equals 2. And then finally, the last one, problem D. I'm going to start the same way in that I'm going to multiply by the denominator, 0.5 minus x. On both sides. Okay, so 0.5, I have to distribute, times 3.5. 0.5 times 3.5 is 1.75. So 1.75 minus 3.5x equals, those cancel each other out, 4 plus 2x. Okay, so I'm going to move the x's to the left by subtracting the 2x from each side. And I'm also going to move the constant 1.75, subtracting that from both sides. So this is negative 5.5x equals 4 minus 1.75 is 2.25. And then finally divide by negative 5.5. So 2.25 divided by negative 5.5 is negative 0.41. Negative 0.41. Okay, so let's finish up here. We've got one more problem to do, and it's one of those batting average problems, okay? So number 7, a softball player has had 8 base hits out of 25 for a current batting average of 8 divided by 25. So I think you would hear someone say that she's batting 320, so 0.320, okay? How many consecutive base hits does she need if she wants to raise her batting average to 400? So 0.400 as a batting average is referred to as 400. Okay, so think about it. It's consecutive at-bats, consecutive at-bats. And so she wants to start with this and get that 320 up to a 400. So we'll say, well, she's going to have a certain number of at-bats, and she needs to get a hit off of every one. And we want this to equal the 400. Okay, so any value of x that makes that true is going to be the solution. All right, so we'll solve this just like we have in the past by getting rid of the fraction, multiplying by 25 plus x. So this is the number of hits that she already has. This is the number of times she's been at bat. She has to get a hit on every next time at bat to get this up to 400. So we need to know how many. All right, so 25 plus x, 25 plus x, and this times 25 plus x. All right, so those cancel each other out. And we have 8 plus x equals 0.400 times 25 is 10. And then distribute the 0.400 to the x. I'm just going to write 0.4x. All right, so move the x's to the left side by subtracting 0.4x. And the constants to the other side by subtracting the 8. X minus 0.4x is 0.6x. And 10 minus 8 is 2. And so when we divide this, it's like 3.3333, right? And so, in context, so 3.3 repeating, well, I wouldn't really say that. So if she gets just 3 consecutive hits, it's not going to be quite enough. She can't get a partial hit. And so I would say altogether, she needs 4 consecutive hits. So even though the rules of rounding would say round that to 3 if you're going to round to a whole number, 3 isn't enough. So this is a time where you would actually bump it up to the next number, which would be 4. And then she would have actually a batting average over 400, but 3 isn't quite enough. All right, that's the end of the assignment. I hope that was helpful.